Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to the Reliability Matters podcast. I'm so glad you're with me today. For those of you who are counting, this is episode number 105. Today, we're diving into conformal coating best practices. With the explosion of Internet of Things, IoT, the electrification of vehicles, and the miniaturization of circuit assemblies and associated components, many of which are operating in harsh environments, the need for conformal coating has never been greater. Need to conformal coat your assemblies? Where does one start? What materials should one use? Should it be applied in-house or through a contract coating house? What are the best practices for material selection, application, inspection, thickness? So many questions. To answer these and other questions, I invited a conformal coating expert to speak with me and you and hopefully shed some light on this subject. My guest today is David Greenman. David began his career in the conformal coating business working at Concoat, first distributing Humaseal products and eventually manufacturing them under license for Europe, the Middle East, India, and Africa. After 25 years of distributing then manufacturing Humaseal products under license, Chase Corp, which owns Humaseal, purchased Concoat, where David now serves as Director of Humaseal UK, Europe, and India, and where he's also responsible for corporate responsibility as well as supporting Humaseal sales and technical teams. Earlier in David's career, he qualified as a radio, TV, electronics engineer, became a member of the Society of Radio and Electronics Technicians that was eventually absorbed into the Institution of Engineering and Technology, and he's still a member there. David is a member of numerous British standards committees for conformal coatings and resins beginning in the mid-1980s, and as a matter of fact, he's now chairman of one. He is also on an IEC committee as the UK specialist on conformal coatings. David has also recently been elected as chairman of the newly formed United Electronic Coating Association. So, let's dive into coating, shall we? Without any further ado, I'd like to welcome David Greenman to the show. Hey, David.
Thank you, Mike. It's a pleasure to be here.
It's a pleasure to speak with you. Thanks for agreeing to be my guest today. Or actually, I think it's a little bit more voluntold, right?
Yeah.
Someone said, hey, talk to this guy. No, but I do appreciate it. And, quite frankly, this is not a commercial show, but when I think of conformal coating, when I think of colas, I think of Coca-Cola, right? When I think of conformal coating, Humaseal just kind of drops into my head as the placeholder for the product. Not to endorse or not endorse a brand, but it's to me, at least from my vantage point, it seems to be kind of the Coca-Cola of conformal coating products. I'm sure you won't argue with that statement, right?
Absolutely not. We've been around for over 60 years now in the conformal coating market. Humaseal started out in the US and is now a global company with manufacturing sites within Europe and within India. And we have our remaining manufacturing licensee in Japan. So we truly are global now, we've come a long way in 60 years.
Yes, and that's 60 years in the electronics world. That's like 6 million years. I mean, it's kind of measured in dog years. You, in your bio, I had mentioned that you were a TV engineer, back in the day, and I think you're still obviously you're still experienced in that, although TVs have changed a lot. I believe some of the earliest conformal coatings, and I'll put air quotes around conformal coating, was on old television sets because they tended to cover their boards with rosin flux and just not clean it. That seemed to be kind of let's call it the poor man's conformal coating. Does that ring any bells?
It does, and you can actually go back before then to WW2 when they were putting radio systems into planes and giving it to the troops. and shipping it out to the Far East. And to protect it against the environment it was going into, the high humidity, they used a product called shellac, which comes from the shellac beetle.
I took
And
wood shop in high school, and we shellacked a
yeah,
lot of projects. Yes, absolutely.
absolutely. And that was what I think of as the original conformal coatings. But no, you're quite right. I remember back in the 60s working on a radiogram, we called them in those days, and which had come back from the Far East for a person that had been working there, and believe it or not, it was covered in shellac.
Amazing.
So,
I
yeah,
wonder if the dielectric properties of shellac are as good as modern conformal coating. Maybe not.
probably not.
Yeah, probably not. Well, it worked, and I don't think I'm not convinced they left the rosin flux on the board for any other purpose than they just didn't want to remove it. But
Correct.
I remember taking things apart when I was a kid. I've said this on the show before. I used to get in a lot of trouble with my parents because I was very curious how things worked. So I took things apart. I was not at all curious of how to put it back together. So my parents would come home from work and various appliances would be in various stages of disassembly. But it's just as well. I was lucky, I guess, as a kid because I did take apart some televisions. And back in the days of CRTs, they held a charge, right? You
Oh
could
yes.
you could be killed off a junkyard TV back then,
Yeah.
even
You could
today.
get a rather nasty burn. I
Yeah,
wouldn't
yeah.
say it would kill you, but yeah.
All right, let's start.
Anyway, yeah.
Let's start at the beginning. Most of my audience, overwhelmingly, most of my audience is in the EMS space as we are. Some aren't. I have some subscribers that kind of orbit around our sun, but not quite close enough. So let's just not assume anything. Let's start with a beginner's mindset. What is conformal coating? And well, let's just start with that basic question. What is conformal coating?
Okay. Well, basically, it's a thin polymer film that conforms to the profile of a printed circuit assembly. It protects it from the operational environment, so it filters out contaminants, protects against dendrites, maintains surface insulation resistance, and in recent work, it reduces and can control tin whiskers.
So when
The
we
thing
talk
to
about
remember,
dendrites,
yeah,
we just lost a few people. So my job is to bring everyone up to speed. So dendrites would be basically electrochemical migration, which is metal crystals growing on the board.
absolutely.
And there were some other benefits as well. Basically keeping nasty stuff off the board, right?
Yeah, that's it. The thing to remember is a conformal coating, and it doesn't matter what the resin base is, it doesn't matter where it comes from. Moisture permeates in and out of the coating, so it's basically acting as a filter. And if you look at a decent technical data sheet, you'll find that it states insulation resistance. That's normally done at 25 degrees Celsius, 50% relative humidity, and will also state moisture resistance, which is 85, 85. So that is a fully saturated coating. And you'll notice that there's a delta between the two.
Yeah.
And that's primarily the lowest insulation resistance you will see with that coating. So the design engineer can then look at that and say, right, well, that's not going to affect my circuit. Or if he has a low voltage sensor of some description, it may or may not. So at least he's got that option.
Right. So just to put a bow on the rudimentary part of our conversation, it's a protective layer, kind of a raincoat, so to speak,
Yep.
over the board, on the surface of the board, to protect it from the harsh, cruel world that we seem to be throwing assemblies into, particularly these days. When I think of conformal coating, and as you just confirmed, I think of it as a protective barrier to keep bad stuff out. There are other advantages to conformal coating in addition to just that. Can you, or are there, maybe I shouldn't be so presumptuous, are there other advantages to conformal coating other than just simply to avoid water spills and dust and things like that?
Well, I think one of the biggest benefits, and especially in today's marketplace, with the ever-increasing packing density and the reduction in conductor spacing, is that actually a conformal coating will allow you to reduce your conductor spacing by up to 80%. And that's very relevant in, say, high voltage circuitry, etc. And it's one of the benefits that's been around, from day one. The other things, of course, it can help protect the components from vibration. It protects against a certain amount of condensation, and also incoming atmosphere. One of the interesting things I read recently is that a major computer mainframe manufacturer that's been putting units out into India, etc., in air-conditioned rooms, have started to conformally coat, whereas in the past they wouldn't, primarily because of the sulfur in the polluted air that comes into those major computer rooms.
And that was a big problem in LED lighting because of I think they use a silver backing material,
Yep.
and the sulfur in the air and the silver created all sorts of nasty growths on the board and rather quick failures, if I recall.
Yeah, I did read that one as well. Yeah.
So walk me through. There are different types of conformal coating materials. It's not shellac for everybody anymore. Those days are gone. Walk me through the different types of materials. Let's start by identifying them, and then we can kind of dive into the differences between those.
So you should be able to see on the screen now the major resin bases that are utilized to make conformal coatings. We start
And go ahead and walk through them as well, because some of my audience listen to the show and some watch the show. So let's talk for the benefit of those who are not seeing. So just explain what we're seeing on the screen.
Okay, so we have 5 different icons, each one covering a resin base. We start with synthetic rubber, and that's a development over the last 20 years, but it's proving to be quite a robust and excellent base for a conformal coating. And in fact, it has one of the best moisture permeabilities, or should I say the least moisture permeability of the whole range. Next, we have UV Curable. These came around in about in the early 20,000s, and 100% solids, polyacrylics, and they cure with UV light of various wavelengths, and we'll cover a bit more of that later on in this chat. Then we come on to what we call the classics. We've got the acrylics, which are one of the best classic moisture protection materials. It has been used extensively by the military, and is a good general purpose base for a conformal coating. Then we have urethanes, polyurethanes. If you need a bit more chemical protection or salt protection than you get with the acrylics, urethanes are the ones that were then selected. Finally, we have the silicons. Silicons have been around for some time. They are primarily for high temperature operation, anything 200 and above. But they are now being slowly superseded by the UV curables, which we can take up to 150 plus degrees Celsius continual operation temperature. Just to give you an idea on the permeability. Okay, so this graph shows you how we rank the resin bases by vapor permeability. And it's based on an ASTM E398 test, which is a known test. And as you can see from the graph, the degree of moisture permeability decreases as you go down the graph. So, believe it or not, the worst product for vapor permeability is the silicons, followed by the polyurethanes, the acrylics, two-part epoxies, but then at the bottom, giving the best results, are the synthetic rubber and the UV coatings. And this is a test we did a few years ago, which, to be honest, even amazed us that the silicons gave the worst performance.
Now, when you say synthetic rubber, when I think of, from my 30,000-foot press box view, when I look at conformal coating materials, I think of acrylics, silicons, other types of materials. I've never heard of synthetic rubbers before. Is that synthetic rubber product known by another classification, or are they called synthetic rubber?
Under IPC CC 830, it is now listed as synthetic rubber, SR. And
SR, okay.
And yes, it's a resin that is more flexible. And more recent ones have higher temperature range. Again, we can go up to 150 degrees Celsius.
So we talked about the different types of materials and which are better and have different attributes, I should say. Are there a specific application-based or maybe industry-based conformal coating materials? In other words, does the LED industry gravitate toward one type of product? Does the auto industry gravitate toward another type of product or material?
I think if I may, before we move on to that, I know there will be certain suppliers out there will say, well, what's missing? And what's missing is...
Someone's out there that goes, you never said our stuff, right?
So, and as this is a non-commercial...
Let's throw Parylene out there. Parylene is missing because that is
missing.
That is A, a material, and B, a whole application process, right? It's very different. Yeah. So Parylene, the Parylene guys are going, hey, what about us? So let's identify them.
What I used to call the surface modifiers, which are now being called by IPC CC 830 ultra thin conformal coatings. These are the fluorocarbon nano coatings that are based on the water repellent properties of the lotus leaf, where everything balls up, where water balls up and then rolls off. In the European standards at the moment, they're not recognized, but hopefully in the next few years we will. They are different to conventional conformal coatings. They go down at very thin levels, even to a certain degree, nearly as thin as Parylene. And it's going to be interesting to watch them progress over the next years. They have good water repellent properties, but we need to see the other properties that we expect a conformal coating to have and how they perform. But I would mention them in passing.
Yeah, when I've been to a number of conferences where nano coatings are promoted, and they're not quite in this, under the same banner as conformal coatings. They don't, at least at the moment, they don't seem to even advertise some of the other attributes of conformal coating outside of water repellent, moisture repellent. But I've seen them in stencils. People will nanocoat their stencils for better release, solder paste release, and for easier cleaning and things like that. The word nanocoating has been exploited beyond a reasonable factor. When I go to the auto store and buy car wax, they all says with nano coating, and who knows if that's actually truly technically nano coating, but the word has kind of morphed into the consumer world as well, and it's being applied in all sorts of creative ways. Let's say
absolutely.
But it is interesting to see.
The advertising boys have got hold of it.
yeah, right, exactly. All of a sudden, it's turtle wax with nano coating. So the original question, and then we got off track a little bit, was: are there application or industries favorites in terms of conformal coating materials? Does the auto industry gravitate toward a certain type of material? Does the LED market or other markets gravitate toward others?
Well, the thing with, let's start with LED applications. To start with, you need a clear, if you're going to coat over the LEDs, you need a clear conformal coating that will remain clear throughout its life. So the first thing you've got to look at is the base resin. Will it age? Will it change color with temperature and age? So basically that eliminates the polyurethanes straight out the window because they age and they discolor. Also,
Not real good when you're trying to get light through it.
Quite. That's the whole point. And the other thing you have to ensure is that there's no UV tracer. You may know that in good quality conformal coatings, they all contain a UV tracer that fluorescizes under long wave UV light for inspection purposes, for some application purposes. But again, that product, as it ages, it loses its fluorescence, but it also can change color. It can become a light straw color, which again is going to upset your light permeability of your coating for LED applications. Moving on from LEDs, looking at automotive. Automotive are usually high volume, so the UV curing materials are very good for that, and they are now overtaking the traditional solvent-based materials. And we have a number of automotive manufacturers that are now using our UV curables, even from the ones that we developed back in 2004, 2005, and released in 2005. They're still there and they're still doing the job. Industrial controls, that normally depends on the end environment that the product is going into, and the coating is selected accordingly. But again, we're going to discuss a bit more of that later. White goods, again, it can be high volume. So predominantly in the white goods market, we're selling the UV product. And
when you say white goods, explain what that is.
Okay, fine. White goods. So it's your washing machines, your tumbler dryers, your dishwashers, your toasters, your kettles, and even some of the more advanced mixing systems. They've all got control boards inside that obviously could be, especially in your washing machines and your dryers, could be exposed to high humidity, to high temperatures, etc. And in fact, there is for one of the major American white goods manufacturers, I won't mention names, they have a bleach test, which is basically you coat a board, put it in a pressure cooker and boil it for a few hours, effectively. Not quite exactly the same as that.
So it sounds like the appliance manufacturer is using an appliance themselves, right? We come from the cleaning world. I'm in the cleaning business, and our to some degree, not so much anymore, because boards have become so difficult to clean now. But one of our competitors was dishwasher, residential dishwasher, back in the day. So there are industry specifics. They all have their favorite, and they all have the one that works best for their application. And it sounds like a lot has to do with the design of the board and the environment in which those boards are going to perform.
Absolutely.
So if one was to choose to apply conformal coating, and we'll get into what's driving the conformal coating business explosion shortly. Let's say, okay, I need to conformal coat, and I'm going to conformal coat in house. I'm not going to send it out to get done. I'm just going to bite the bullet and do it. What type of equipment, manufacturing environment, safety concerns, and all that would I need to at least consider based upon whatever choice of material I choose?
Well, let's start at the beginning and look at the most basic way of applying a conformal coating, and that is by hand brushing. It's not used much these days, normally for prototyping, but it should be done in an extracted cabinet preferably with some long wave UV light to activate the UV tracer we talked about earlier, so the operator can see where the coating is going, and more importantly, where it shouldn't go if he's a bit cack-handed. And of course, if he's using a solvent-based material, the extraction system needs to be explosion-proof. It's very important that there's an extraction system, because without an extraction system, whatever the product, the operator would have to wear a full face mask, preferably air-fed. Also, the operator should be wearing gloves when handling any product. So that's the sort of start point. The next stage would be hand spraying using an extracted spray booth, preferably with a turntable to be able to rotate the board through 90 degrees, because the best method with hand spraying is to give it a covering, turn it through 90 and repeat that 4 times. You build that up, and if it's a solvent-based material, you'll repeat that 2 or 3 times, depending on the product, to get the required thickness and coverage. And especially with modern day surface mount, where we'll come on to that later, but edge coverage is becoming a problem. So from hand spraying, again, it preferably have a UV light and obviously extraction, but all of that should be explosion proof when using solvent based. Next, a method that was used quite a lot in the 80s and 90s is dip coating, controlled dip coating with a dip coating machine. It is still used today, but often for horizontal dipping, where there are components that are difficult to mask, or the selective coating system cannot make its way through the array of components. And dip coating, it should be a purpose-built system, have its facilities for extraction, and a controlled immersion and withdrawal speed. And that is the important thing with dip coating. But you can also have inline systems, and some of them will have built-in curing. So it's not, as I say, it's normally very specialist these days. It's not as relevant as it was in the 1980s and 90s. And finally, of course, we have the robotic selective film stroke spray coating systems. This eliminates masking, but obviously it still needs extraction. But they are now becoming very, very popular. Even with the military that originally discounted them because they felt that it put the coating down too thick. Whereas now, with today's components and packing densities, edge coverage is the big thing. Okay, so I think that covers the application methods, and what's used to be used and what's used today.
I would imagine that some of the decision criteria for application method is based upon the types of populated components that are on the assembly. For example, if one has a BGA, they're probably not going to brush on the conformal coating, because I can see an advantage of at least hand spraying, because you can get kind of on a 45-degree angle and help push the material underneath the BGA, and other low profile QFNs, things like that, probably don't lend themselves to hand brushing a whole lot. But I'll tell you, I have to be candid. When you said certain solvent-based ones that have to have explosion-proof cabinets and basically PPE, you kind of just talked me into sending it out to a contract coder. That's a lot of safety stuff going on. And we do in my day job. We have relationships with contract coating companies because best practices is generally to clean before you coat. So
Yeah.
we support quite a few coaters, and I've visited them over the years, and it's funny. I'll walk into their place and overwhelmed by a smell, and I'm like, "Don't you smell that?" And they go, "Smell what?" I think they're just too used to it, right? But definitely, if one is going to embrace the idea of conformal coating in-house, they really have to go in eyes open, because it's not just one more standard process. It really is a specialty. There's a lot of decisions that have to be made, and equipment to buy, and safety protocols to follow, and that involves a team of people from your company to sign off on that. So, that's why I'm happy that you're with me today, because it is a growing segment within our EMS space, and you kind of have to know what you're doing up front in so many regards to make it successful, not just successful from a coating standpoint that it will provide adequate protection of your product, but successful from a implementation standpoint as well.
Absolutely.
So as on the subject of ensuring success, if I came to you, or if anyone came to you saying, "Hey, David, we need to conformal coat," you would probably, I don't know enough to tell you what you need to know, because I don't know what I don't know. So you're the expert. So I would imagine you would turn around and say, "Okay, Mike," and then you'd list a series of questions so that you can drive me or steer me toward the most appropriate solution. What types of questions do you ask your prospective customers?
Well, we'll always start with is, what is the operating environment of the PCA? Is there chemical contamination? What is the operating temperature range? What is the potential thermal cycling requirements? The preferred application and curing method, and to a certain degree, the volume to be produced. As we were saying earlier, that a client getting into conformal coating, he's got to consider there is a lot of upfront costs, as you indicated, and what he's got to consider is he prepared to make the investment, and will long term he have a sufficient boards to conformally coat for a return on that investment? If not, go to an EMS, go to somebody that's experienced in applying the coating. So the volume to be produced is one thing, and that helps us, and also his application method, his preferred application method, that helps us select the best coating. So you start with the environment, you start with the temperature, you start with the application, and the volume, but also something which I'm sure you will like is, are the boards going to be cleaned before coating? 20 years ago, when I was doing presentations, I had a slide that said, "No clean is no option when conformally coating." And in those days, it wasn't an option. And the military still clean before coating.
Yeah.
So, it tells you something.
I've looked at, in my presentations, I make the same point. It benefits me to do that. But even though it benefits me to promote cleaning, it really needs to be cleaned. And it's just like, back many, many years ago, here in North America, we had a company that painted cars. And the company was called Earl Scheib. Earl Scheib was the owner, and he was famous for his radio spots. And he'd say, "I'm Earl Scheib, and I'll paint any car for $29.95, right? $29.95. How do you paint an entire car for $29.95? Well, you bring it in, you don't wash it, you don't prep it. There's no surface prep. You just paint it. And if you don't like the color, in 6 months, the paint will peel off anyway, and you can do it again. So surface prep is so important when it comes to paint, when it comes to any kind of adhesion process. Surface energy, has to be right. And this gives me a good segue for an anecdote. I was hired as an expert witness several years ago in a civil litigation matter where an OEM hired a contract manufacturer to assembled boards. And these boards were going to be potted, not coated, but it was a similar concept, potted and placed into the ground and without a power source. So these boards were running off a battery, a 10-year battery. The boards would send a radio signal up to a nearby receiver, which was connected to a traditional power source. And after about 3 months, the board started failing. The product failed because the battery was drained. And they couldn't figure out why the battery was drained. Well, they had a number of issues. They had calf, which has nothing to do with cleaning. They had dendritic growth and parasitic leakage. When we dug into the details of how they manufactured the product, they washed the boards in an inline cleaner without a chemical additive because they had water-soluble flux, which meant all the polar, all the non-polar residue species from all the other processes in assembly were left on the assembly. So they had dirty boards, and then they didn't bake out the boards at all, zero bake out, and they potted them. And they thought, well, they're potted, so they're protected. Well, what they did is they created this sarcophagus. Like King Tut was buried in a coffin with a lot of his possessions, this board was buried in a silicon sarcophagus with all of its possessions. And the possessions were moisture, conductive corrosive residues, all this stuff. And guess what happened? There was enough moisture within the layers of the board to create the catalyst effect for electrochemical migration, and there was enough moisture to react with the corrosive residues and conductive residues to create corrosion. So the batteries drained because of parasitic leakage and other factors, dendritic growth and calf, and they thought they were fine because they coated the board. They would have been better in that case, or potted the board, but they would have been better in that case not potting the board, because then at least the moisture would have a chance to outgas. So you have to be careful that you're not just protecting what's around the board. You're going to encapsulate everything, all the sins of the process, if you don't prep it properly. I'm not saying everyone should clean. What I'm saying is you're going to trap in, and you're going to trap out. And I think people don't consider the former; they consider the latter, right?
Yeah. They don't understand that conformal coatings and potting compounds trap contaminants underneath.
That's right.
And as you've described, and that can lead to failures. And, we've had to get used to no clean. But if you're running no clean, as I think we're going to talk about later, you've got to control your process.
Yeah.
Otherwise, you will be trapping rubbish underneath your coating.
Sure. Yeah, absolutely. So we talked about what questions you would ask a potential customer, which are great questions. What types of questions, and I don't want, I'm not trying to steer this into a partisan discussion. We don't want to make this a commercial, but in the generic sense, what types of questions should I be asking potential suppliers?
Okay. So very similar to the previous answer. The things you should be asking is, will the conformal coating protect my boards against the operating environment? So you would have to describe that operating environment. Are there any limitations in the application method? They need to look at the application method, and the coating has to match that application method. And also curing. How do they want to cure the board? How long are they prepared to wait? Again, it comes down to throughput, to volume. And also, depending on the manufacturing process, are they going to clean the boards? Do they and the questions they should ask is, do I have to clean my boards before putting your coating on? And then we would describe, understand what they're leaving on there, what their process is, and maybe make some recommendations. And the final thing, which a lot of people forget, is there a minimum requirement for the surface energy of the board before conformal coating? Because that is going to affect wetting, it's going to affect adhesion, And as I think we talk about later, we look for greater than 38 dyne centimeters of surface energy on a board. And that's after it's been right through the process. All the different chemical processes the board go through before it gets to the conformal coating stage. And that's what they've got to watch out for. And that's the sort of questions I would expect a client to ask.
Excellent. We're going to take you in a time machine now, David. In a 2018 interview with one of your colleagues, it wasn't yourself. We'll get into one that you were in a moment. He stated that miniaturization of components has made them increasingly more difficult to coat. Now, that was 2018. They've just gotten smaller since then, right?
Yeah.
So do you agree with that statement? Has miniaturization made it more difficult to coat? And if so, what's being done at coating companies to address or mitigate this challenge of the ever decreasing footprint of components?
Okay. If you go way back before then, when we had through-hole technology, axial components, round components,
When we had actually components we could see with our eyes.
we could see with our eyes.
Yeah.
Absolutely. Easy to coat, no problems at all. And as we've got into surface mount, and as it's developed and the components got smaller and smaller, tighter packing densities, narrower track spacing, and the big thing is the shape of the capacitors and the resistors these days. They're square. They have sharp edges. And one of the big things people don't look at when they're conformally coating is the sharp edge coverage.
I would imagine it would be thicker on the surface and thinner on the sharp edge, right? Because the stuff wants to wet out. It gets thinner.
It.
Yeah.
It's got to define, its gravity pulls it away. So basically, what is happening now, we are seeing with some companies that are not applying the coating correctly, putting it down too thin or processing it too quickly. They're getting hardly any coverage on those sharp edges. Then what you can actually get a dendrite that grows across from one component to the other. If you've got a contaminant on the surface, if you've got a positive and negative opposite each other, this is what we're seeing. So we are certainly looking, and we are now starting to talk about improving sharp edge coverage and how you improve it. And we'll be talking more about that at the SMTA conference. Mr. Chris Brightwell, R&D manager for Humasil, will be there, and we'll be discussing that. That's one of the things he'll be discussing.
With factors including the implementation of electronics into harsh environments, environmental regulations, and sharp edge corners on components, as you just mentioned, that has driven the need for advancements in conformal coating materials. You talked about ways you're addressing the sharp edge and things like that. Well, that seems to be creating a challenge for conformal coating companies, particularly the environmental side, because kind of the rule, I live in California, we're a little bit nuts out here, right? So, and kind of the rule here is if it tastes good or works well, it's either fattening or illegal, right? Just pick your example. So I would think that one of the challenges in your world is allowing your products or designing products that are robust enough and work well and still can get through the door. That and so many other challenges. Let's kind of focus on the environmental side. What are the environmental challenges in the conformal coating materials world, and how do you get around it?
So you mentioned California. I'd just like to relate one story I heard many years ago.
That's not true.
In California.
I'll deny it. Another story. Okay, go ahead.
When California was starting to look at solvents and getting rid of solvents in varnish, i.e., could be conformal coatings.
Mm-hmm.
And apparently there was a furniture manufacturer that was employing, I think it was 12,000 people somewhere in California. And they were told they had to change from a solvent-based varnish and all their furniture. And I think the number was 3 months. And they said, look, we can't do it in 3 months. We've got to evaluate all the water-based stuff. We've got to see if it works and what the lifespan is. And they were said, no. Government said, no, you've got to change within 3 months. So they upped sticks and moved to Mexico and continued to use solvent-based. So 12,000 jobs were lost.
Yeah, well, that's in the cleaning world. We have, throughout the United States, in urban areas mostly that have been known to have air pollution issues. We have AQMD, which is a government agency, Air Quality Management District. I think it's under the EPA. And in some areas, like Southern California, which has historically been known to have bad air quality, we have the South Coast Air Quality Management District. So basically, they come to work. They have a calculator on their desk with only 3 buttons on it. Only 3. Divide by 2 equals. I'm convinced of this because the VOC regulations for areas in our country that control VOCs is 50 grams per liter. In Southern California, it's 25. Just cut it in half. Whether it works or not, that's someone else's problem. But just cut it in half, which is good. I mean, I appreciate that. I'm a native of California, and I remember, when we couldn't see our mountains, and your chest hurt when you breathed in, hard. And those days are largely behind us, thankfully. So between the electrification of vehicles and IoT and miniaturization and all this stuff, have you witnessed this is probably more of a rhetorical question, have you witnessed an increase in the demand for conformal coating? I would assume the answer is yes. So let me rephrase it to, how much of an increase have you seen in the last several years?
Well, okay, so let's say over the last 5 to 10 years, more and more electronics are being put into the vehicles. Every time I buy a new vehicle, there's more and more electronics in there to learn about and understand. So yes, we have seen an increase in the use of coatings in the electronics industry. And because it's a high volume industry, most of that has been UV cured coatings because it cures within 5 seconds under the UV lamp. Whether it's LED or whether it's arc, and we can come on to that in a minute. So yes, there is an increase, and of course, it's got to be high rel. It's safety critical. So, and there are certain manufacturers I know that are now, and you may know them, that are now looking again at the potential of cleaning a board to aid the long-term reliability and the high rel safety concerns.
Yeah, I think both the conformal coating industry, your world, and the cleaning industry, my world, are basically riding the same wave. We're next to each other on our surfboards, but we're definitely riding a pretty tsunami-esque wave. It's
Absolutely.
For all the same exact reasons, right? For the exact reasons. You talked about UV coatings a few times. I know that you can have just a air curable coating, and you can have a UV coating that cures in, I think you said 5 seconds or something, which is pretty impressive. Other than the time factor, are there advantages to UV curing that maybe air curable products don't have?
Okay, so UV curables, obviously on a printed circuit board, you're going to have shaded areas. So you have to have a secondary cure mechanism. And that secondary cure mechanism needs to work within 72 hours. And it needs to cure the product that has not seen the UV light to a level where it has the same electrical properties as the fully cured material. Now, if you have a large QFP and your coating has migrated underneath, it won't see the UV light, but it will cure and it will get the original properties, the same properties as the cured material. Problem is, if you lift that product off, you're going to find it's not as solid as the material that's in UV. It may be even slightly sticky, but it is still giving you protection. And that is one thing that we find we have to explain to customers with regards to UV cured coating.
Yeah, I hadn't thought about that. That it obviously it only cures when it comes into contact with UV, and with the proliferation of bottom terminated components, BGAs, things like that, QFNs. That's not seeing any light. It's not seeing the light, so so it eventually has to catch up. But still, I would think there's still an advantage to have it the majority of the surface cured in 5 seconds, because then it can go on for further processing as it naturally air cures. Without that, you're not touching the board. You're not moving the board to a next process until it's at least the majority of the surface is cured.
That's it. I mean, this is the thing with a solvent-based product. You could, and you want to get it fully cured, you could have a 10-meter oven after the coating system, and that's taking up floor space. It's costing money. With the UV cure system, it can be 1 meter long. Sorry, I'm talking in European units here.
Oh, we can figure it out. I think we're the last country standing that still uses imperial, but which we got from you, by the way. So thank you for giving us something that you quickly switched out of.
Well, my wife refuses to use metrics. She still uses feet and inches.
Yeah.
So
I have to convert. I have to convert everything. I have to convert it because my brain is just programmed in feet and inches, and Fahrenheit, and all that stuff.
Yeah.
In a prior interview you gave, you talked about energy savings with LED curable, and I hadn't thought about that. It takes a certain amount of energy to light up a bulb, whether it's a UV bulb or a normal incandescent, light bulb. I hadn't really thought about the energy savings, but your company, and maybe others too, I don't know, but certainly you were promoting the idea of LED curable, which obviously we all know in our civilian life that a 60-watt equivalent on an incandescent bulb that would run 60 watts is like 2 watts of LED power. So clearly there's a savings there. Tell me a little bit more about the LED curable materials. Are they, and how fundamentally different they are from a standard UV curable?
Okay, so if we just go back to the original cure methods, arc curing with an arc lamp or with a microwave system, the arc lamps would have a limited lifespan, probably max of 600 hours. They would draw a lot of energy. Now, the beauty of the LED cure systems is that, as you've described, it uses low energy. But on top of that, we've found out that with the right UV cure activator within the product, and with the long wave UV light curing system, we actually get a deeper cure quicker than we do with arc. So not only are we saving energy with LEDs, we're saving energy on the amount of time the board is underneath the lights. So a lot of the base resins that we use for the UVs remain the same, but we have looked at new resins to meet some of the requirements of the industry for flexibility. One of the things with regards to lead-free soldering, your soldering, as you know, at a much higher temperature, your flux is becoming vitrified. And what we found is that in the some coatings, when they're put over the vitrified flux, and go through extreme thermal cycling, you're getting cracks because of a differential in coefficients of thermal expansion between the coating and the vitrified flux. So we've developed UV curable coatings now with additional flexibility that will survive that. They can survive 3,000 thermal cycles on top of vitrified flux. Not that we promote that. We would rather see the flux cleaned off to give us a surface. As I think I said earlier, if you're running a no-clean process, you should really do process validation on that process. You've got to look at board handling. Are any of the operators handling the boards without gloved hands? Are they putting finger salts on? What are you leaving on there from previous processes that could, even flux, as I'm sure you're aware, will, if it's not fully activated, could be a contaminant, could cause a dendritic growth, could cause, electrochemical migration. So, there's a lot of things to consider. But the LED curables we are now very pleased with, and we've solved a few problems with them.
One of the things I've wondered about is, particularly with bottom terminated components with large ground planes and things like that, is thermal dissipation is a concern. Now more in the surface mount business than it was back in the through-hole days. Does conformal coating have a positive or negative effect on thermal dissipation?
Okay. Depending on the product, depending on the components that are on there, conformal coatings never used to restrict or increase the thermal energy within the product. But now one of the concerns is with high voltage switching units, especially in electric vehicles, generating a lot of heat. Is that heat getting out? So this is something we're working on, and it looks possible to get a conformal coating that will assist in that thermal release, that releases it through. I mean, in the past, it was never a problem because you didn't have that degree of energy, of that heat generating electronics, but now you do. So It's something we're looking at seriously.
Okay, I'm going to put you on the spot as we get near to wrapping up. You need to have a product that cannot fail. And if it fails, you die. So there's no pressure. And that product needs to be coated. And as I said, your life depends on the reliability of this product. And you can choose anything you want. Obviously, you're going to choose Humiseal. I don't think you're going to go, we're going to go with brand X. But outside of that, is there a preferred coating material that you would choose, knowing that the stakes are very, very high?
I think in today's marketplace, with the coatings that we now have, I would choose one of our latest UV materials. Not wanting to advertise, it's UV 550, and it runs up to 150 degrees Celsius. It's got good flexibility. It survives 1,000 cycles, minus 140 to plus. Sorry, minus 40 to plus 150. Get it the right way around. And that is what I would choose if it was a safety critical product. Yes.
Okay, excellent. And finally, get out your crystal ball. What's the future of conformal coating materials and processes? Where do you see, without divulging company secrets, where do you see kind of generically the industry going, both in terms of the consumer and the and the manufacturers of the materials?
If we start with manufacturing, there's more and more regulations being brought in about the solvents that one can use. So our classic materials, especially the acrylics, which are still widely used throughout the industry, they're going to disappear because eventually, and in fact, a good friend of mine, John Werriold, who was president of Humasil in the old days when I first started, he and I had been saying, 10 years time, 20 years time, solvent-based materials are going to disappear. Here we are, 30 years later, and we're still selling tons of the product. But the regulations eventually are going to stop us. We've had to change solvents on quite a few of our solvent-based materials to meet the regulations. So I think the UV curables, 100% solids, is the future. And maybe the synthetic rubbers with the right solvents, and both products with an addition to assist with sharp edge coverage, because that's where I think the industry is going to fall over, especially with condensation. We've been involved with the National Physics Laboratory in the United Kingdom, who have developed a testing method for creating condensation or a micro layer of moisture. And that's proving very interesting, and we've got some very good results out of it in some of our products. So that's the future, I think, is 100% solids, sharp edge coverage, and making things safer and more reliable.
And I'll add to that prediction that neither of us are going to be out of a job anytime soon. The industry is, yes, I mean, who knows these days, right? Crazy things these days. But in terms of the proliferation of electronics into harsher and harsher environments, the miniaturization of electronics to the point where there can't be even a dirty thought between components without shorting them out. And the increasing expectation of reliability. The auto industry is a great example. You know, I have a 1968 Ford Mustang that has one electronic component or one electronic accessory. Everything else is electrical, and that is the AM radio. You know, so if 100% of my electronics failed in that Mustang, I would just not listen to the radio. Imagine if any electronics failed in a current automobile, particularly the upcoming autonomous vehicles. It could have devastating consequences. And I think even Class 1, IPC Class 1 electronics, just consumable kind of quote-unquote throwaway stuff, still has an expectation to work. Even though nobody dies if it breaks, the company's reputation may die. The recall expenses might be catastrophic. So, and because electronics are going out into harsh environments now because of miniaturization, all the things that we spent the last hour talking about, it is so easy for those parts to fail. And we have to go through extraordinary measures to keep those parts reliable, keep those products reliable and functioning well, whether it's a safety concern or just a practical recall avoidance procedure, whatever the case may be. I don't think either of us are going to be out of a job anytime soon. At least our industries won't.
Quite. And hopefully the industry is going to get back to cleaning as well before coating.
Oh, that's already happened. That's already happened. The tide raises all boats, and we're one of the boats next to yours. So cleaning has very quickly become mainstream. Not quite mainstream again, but very close to mainstream. And people are reluctant. They're trying everything else. You know, they're hiring witch doctors and doing voodoo dances to avoid cleaning. But finally, you know, people realize that they need to be clean. Probably the same with coating. No one wants to coat if they don't have to. Nope. You want to do as few processes as possible. And you know, if there's no other solution, then they coat. If there's no other solution, then they clean. It's same thing. If there's no other solution, then they test. It's these are all value adds, but they just need to see the value.
That's it. I mean, the thing is, if they cleaned and coat, their warranty claims would probably drop right off, as you say. The returns, the recalls.
Yeah.
It adds reliability. It adds longevity to the boards and to the life of the product.
Sure, absolutely. And for those companies that plan on planned obsolescence, don't clean, don't coat, right? Just have a 3-month fulfillment plan. Every 90 days, send another product out. That
Absolutely.
Probably is a model for some companies, and there's nothing wrong with that if that's understood up front. Well, David Greenman, thank you so much for being my guest today. For my audience, if you would like to get more information on David and his the company that he directs, I'll have that information in the show notes. If you're listening to this podcast on your favorite podcast app, just click on the show notes and you'll get contact information there. And if you're watching this on YouTube, somewhere down below here, it says show more. Click on that button and you'll see the show notes there. So David, thanks for all of your expertise, and thanks for filling me and my audience in on the details and the technical attributes and the practical attributes of conformal coating. I really appreciate your time.
Mike, thank you very much for giving me the time to talk with you and do this podcast. It's been a pleasure.
It's been my pleasure as well. Well, that's another episode. Thanks for listening or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, or on our newest channel, Amazon Music, or virtually wherever you get your podcasts. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. Send questions and comments, episode suggestions, to Mike at mikeconrad.com. That's Conrad with a K. Be sure and subscribe to the podcast on your favorite podcast app. Or if you're watching this on YouTube, click the subscribe button and the bell icon to be notified when new episodes are released. We release new episodes on the 2nd and 4th Tuesday of each month. Once again, thank you so much for listening or watching. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. And I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the 2nd and 4th Tuesday of each month for new episodes of Reliability Matters.